In this video, I'm going to coach you through some factoring that you're going to run into as you do calculus. I'm calling it freaky factoring because even though it's something you've already learned, it's going to look a little weird and maybe complex, but it's really, really simple. And so we're going to start with some simple examples to kind of get you warmed up. You guys should actually know how to factor this example in part A. We're going to look at two terms separated by the plus sign. So we have this set of factors creating the first term. We have this set of factors creating the second term. And we are going to simply do a greatest common factor type of factoring. So as we look at the two terms, we can see this 15 and the 20. Those coefficients have a common factor of 5. So I'll build my GCF by pulling the 5 out. And then I look at the x factors in each term. I have a power of 5 and a power of 4. And I can take out 4, or x to the 4th power. And then finally on my y's, I see y cubed and y to the 4th. So how much can I get out as a common factor? That's going to be the y cubed. And so that's my GCF. Then I write a bracket for what's still there. And I'm going to bring down the plus sign because there still should be two terms, one for each original term, but written so that the factor, the GCF, is pulled out. So one at a time. 15, if we pulled out the 5 factor, the remaining factor would be a 3. X to the 5th, we removed 4, and x to the 4th, so there's still an x. And all of the y's have been pulled out. So then we move to the next term. Again with the 20, now pulling out the 5 leaves a 4. X to the 4th is what we had, and that's exactly what we took out. So that's gone, but y to the 4th leaves 1 y left after we've removed 3. So we have a power of 1. All right, and that is our final answer. So this is the factorization. Now, that was pretty simple, and I'm pretty sure you could have done that without my help. But I use that example to show you just the steps. Let's review the steps of GCF factoring. When we decide what we're going to pull out for the GCF, it really is the least power. Look at the x's, for example. X to the 5th, x to the 4th. We pulled out the smaller of the two, the 4. And then to determine the power of the remaining factors, here's what I think about. I look at what I originally had, and then I think about what I removed. And subtracting those should give me my new power. So I started with x to the 5th. I removed a 4. So if I subtract 5, subtract 4, then that leaves me 1, and this x is indeed to the first power. So that's kind of the idea of GCF factoring, and you want to go back to the basics when you get to more complex problems and just follow the basic steps of this. So jot this down, pause the video if you need to, and make sure that you know those two basic steps of GCF factoring. Let's look at this in a little bit more challenging example. In part B here, I've got, again, this set of two terms. There's the plus sign, so here's the first set, and this is the second set of factors, making the two terms. In those factors, what is common for my coefficients? So, 63 and 72, both of those divisible by 9. So 9 is my coefficient of my GCF. Now, x is to the 8th power here, and there's also a factor of x here to the 7th power. I'm going to pull out the least power, which is out of 8 and 7, that's going to be the 7. So x to the 7th power is the least. That's the greatest common factor. And then I have this quantity. X minus 5 appears in both sets of factors, both terms. And so I'm going to look at their exponents. I have a 6th power and a 7th power. The smallest one is what I can take out. So I'm going to take out the 6th power on that quantity. And then I'm going to put my brackets down and get ready to write what I have left. So let me put that plus in between them and start with this first set. 63, we pulled out 9. Dividing that is going to give me 7 for my other factor. X to the 8th, but we pulled out 7. So 8 minus 7 is 1, x to the first power. All of the x's minus 5 to the 6th power, all of those have come out, so I'm done with this term right here. Now over here, I'm going to take the 72 and go through the same process. 72, if I divide the 9 out, that's going to be a remaining factor of 8. X to the 7th has been pulled out, and this quantity, I originally had 7, a power of 7, and I pulled out 6. So subtracting 7 minus 6 gives me that same quantity, but only to the first power, which I will not write down. Now, there is one extra step to this. I'm pretty much done with these factors of the GCF, but this could be simplified. So we want to just work with this part right here and make that 7x plus, let's distribute, 8x minus 40 and then combine like terms. So we've got a total of 15x minus 40 in the bracket, and then let's just bring all this stuff down here. So this would be my final answer. Now, you might want to think about factoring this a little bit more. You can think about that. It's not a big deal if you leave it like that, because this is a polynomial. This could be solved if we had to say find the zeros, which I notice in our next example is going to be our goal. Then you could still find the zeros without factoring that. So that's kind of an optional thing. If you want to factor that more, you can. I'm happy with that as it is. It's a usable form. Okay, example 2, we're going to find the zeros. Now, to do that, it's nice to have factors. I think we can agree with that. We talked about that a lot. So let's look at how we would factor this. There's the plus sign. That's going to separate this set of factors from this group of factors here. Same strategy. Let's look at coefficients to start. Now, I'm noticing that this has a 5 and a 4. So if you want to simplify that and make that 20, that might be actually easier. I'm going to go ahead and do it. Then I've got my x cubed and this quantity x plus 7 cubed. I'm just going to bring down this part for now. Okay, so back to the factoring. This set of factors and this set of factors. What do we see common in both? Well, the coefficient has a common factor of 5. Let's build this GCF. The x is cubed and the x is squared. The same x, which power could I take out? It's going to be the least power, so I'm going to pull out x squared. And I have the quantity in both of these terms. I'm going to take the least power of that quantity, which is the cube. X plus 7 will be cubed. And that builds my GCF. Brackets for what's left, and let me put my plus sign so I can make sure I get 2 terms. Okay, this first term, 20x, or 20, let's start with that, 20. We've pulled out the 5 as a factor. The other factor would be a 4. X cubed, we've removed 2, so there's still an x. And the quantity cubed, we've removed all of them, so there's no quantity left that I need to write down. Moving to the second term, 15, take the 5 out as a factor, the other factor is a 3. All the x squareds have been pulled out. This quantity originally had a power of 4. We've only taken out the cube power, so that means there's still 1 in there. There's my factors. This one can be simplified, so we're going to take that a step further and simplify this, what's in the parentheses. Let's pull the 3x through there. So 4x plus 3x is going to be a total of 7x. And that 3 also distributes and multiplies by the 7. So we're going to call that 21. And then everything else can come down. Now here we were asked to find the zeros. So the zeros are where this equals 0. And that is going to give us just factor by factor. That'll be x would equal 0. It would actually have a multiplicity of 2. Here, x would be negative 7 with a multiplicity of 3. And here, 7x plus 21, if we subtract the 21 over and then divide by 7, and then we can reduce that, x will be negative 3. Okay, so these are our zeros, and we are done just by the factoring of the GCF. Crazy stuff is coming, but still the same idea. In B, let's take a quick step and simplify. Bring any of these monomial factors into the front, and let's multiply them. So let's call that 6x and that 3. Well, the 6 and the 3 is an 18, and the x here multiplied by the x to the 5th, we'll add those as x to the 6th. And then I need to bring down the 3x squared minus 1, and that's squared. Okay, so there's a simplified version of my first set of factors. Plus, my second set doesn't look like anything I can do to that, so I'm going to just copy that down. And this is my second set of factors, or my second term. Okay, let's take a look at what's common in both. 18 and 5, I can't think of anything that would be common for those factors, so I'm going to be done with the coefficient. X to the 6th and the 4th. Smallest one is x to the 4th. We'll yank that out. And then the quantity, this is a matching quantity. One's to the 2nd, one's to the 3rd. We take out the smallest one. So this will be the square. Brackets, let's bracket this. The big old plus, getting ready. Okay, one set at a time. We didn't take anything out of the coefficient, so that's still 18. We've removed a power of 4, having it started with a 6, so 6 minus 4 is 2. And we've removed this entire factor, all of it is gone. So this first term is 18x squared. Next set, 5x, 5 it actually is still in there. X to the fourth, we've pulled all of that out. We still have a quantity here. How many do we still have? We started with 3. We took out 2. There's still a 1. First power of that. Okay, we are done with this part in the front, but this bracket needs to be simplified. So let's distribute 15 x squared minus 5. Let me bring down my 18x squared. Combining like terms, final answer, well, not really because we got to find zeros, but next step is, let's see, I don't know, let's see. You guys are probably shouting at me right now. 33, this is what I think. 33x squared minus 5. That's the bracket part. And then bringing the rest down, x squared, 3x squared minus 1 squared. Okay, we got to find zeros. So this is 0 if x is 0 with a multiplicity 4. If 3x squared equals 1, x squared equals 1/3, and x is the plus or minus square root of 1/3, aka 1 over root 3. And you can make that root 3 over 3 if you like. Multiplicity. Look at that power right there. That factor had a power of 2, so this is a multiplicity 2. And last, 33x squared minus 5 is 0. If x squared equals 5 over 33, and x is positive or negative, root 5 over 33. Multiplicity, just 1. That factor had a multiplicity 1. So there's our zeros. Not too hideous, I hope. It does get a little weirder, but it does not change the basics. Pull out the factors that have the least power, and then figure out your new power by thinking of what you started with, take away what you took out, and you have a new power. Okay, so let's go to this last page. Got a lot of examples here. Okay, this one's actually kind of the same. It's getting more complex. Do you see monomial factors? There's a couple right there. So take those 2 monomial factors out. No, don't take them out, excuse me. Simplify them. Let's put them together as 6x. Then I have this x to the 5th minus 2 quantity. That's to the 9th. There's another quantity in there of x squared minus or plus 7 squared. Okay, that's the first set. Now, is there any monomial stuff we could put together here? I'm looking at 5x to the 4th, 9. Make those, say, 45x to the 4th. And then let's bring down the other quantities. X squared plus 7 is cubed, and x to the 5th minus 2 is to the 8th. Okay, you still have 2 terms. They're getting complex, but they're there. What coefficient could I pull out of a 6 and a 45? I know 6 doesn't go into 45, but 3 goes into both of those. So let me take 3. And as far as x goes, let's take out the smaller power, which is a 1. Is this quantity, x to the 5th minus 2, is that quantity showing up as a factor here as well? You notice that there it is. We've got a power of 9 and a power of 8. We take the smallest. So that power of 8 is going to come out. And then I'm almost done. I've got this quantity, x squared plus 7. It shows up in both terms. We've got a power of 2 and a bigger power of 3. We take the smaller power. So we're going to take x squared plus 7 to the 2nd power. Bracket plus, bring the plus in. Okay, one set at a time. You had a 6, you divided a 3 into that. You have a 2 as a second factor. The x's are gone. The quantity x to the 5th minus 2, there were 9 available, only 8 came out. You still have 1. And this quantity has all been removed. Next set, same questions. 45 divided by 3. I think that might be 15. X to the 4th, we've removed 1x, so this would be x cubed. This quantity originally had 3, and how many were removed? 2, so there's still 1 in there. X squared plus 7 still is a factor of that term. and all of the x to the 5th minus 2 have been removed. All right, then you focus on the brackets. So let's simplify this. Bringing the 2 through as a distributive property says 2x to the 5th minus 4. And bring the 15x cubed through. So that's going to be 15x to the, add those powers to the 5th. And 15 times 7, holy moly, 15 times 7. I'm going to give it my best guess. Well, let me think about this. 70, 30, 35. It might be 105. You better check me. But that would be 105x cubed if that's right. You guys can let me know in class if I got that wrong. Can I combine like terms? Only the x to the 5th power. So 17x to the 5th, 105x cubed, I'm putting these in order, and then minus 4. And everything else should come down as part of the answer. Now, I am out of room to find the zeros, which I think I'm supposed to do, but I'm actually okay if I don't. I will tell you, though, that these polynomial factors set equal to 0, you could use your polysolve to figure out the zeros of this. And actually, all of these, you could use your polysolve on those. So this is in good workable form. Okay, now, example 3 is where it gets weird. Notice, take a look at these things. You've got fraction exponents. You've got negative exponents. And in this last example, you get a negative fraction exponent. Nothing like ending with a bang. All right. Not any different. Exactly the same steps. Figure out which of your factors has the least power and pull that one out. And then use this simple formula to figure out what's left. Just be careful because you'll be working with fractions. So when you do this, you need to be a little bit more cautious. Okay, here we go. There are 2 sets of factors. I'm changing my color code. Let me change that again. Okay, this is green here. There are 2 sets of factors creating the 2 terms of this expression. 2 and 4 coefficients. We can take out a common factor of 2. Now, when it comes to these x's, ask yourself, which one has the least power? Is 5 halves or 3 halves smaller? 3 halves is smaller, so that's what comes out. 3 halves. Bracket. Put that plus in there. Get ready for what's left. Okay, the 2's been pulled out. Now, we had 5 halves power. We removed 3 halves power. So what is 5 halves minus 3 halves? 5 halves minus 3 halves, last time I checked, was 2 halves or 1. So x is to the 1 or the first power. I'm going to write that just for kicks. On the second term, 4 divide out a 2 is going to leave you a 2, and x to the 3 halves has all been removed. So this is my final answer right here. That's it. Okay, works the same with negative exponents as well. 9 and 6 are coefficients. We can get a common factor of 3. X to the 8th or x to the 9th. Smallest one for x is the x to the 8th. Now on the negatives, for y, the powers of y here, -2 or -3. Which one is the least? Negatives can be tricky, so be careful. -3 is actually less than -2. So -3 is the exponent that we pull out. And then bracket time. Okay, 9 divided by 3 leaves me another factor of 3. X to the 8th, all been removed. No x's in that term. We had y to the -2. This was our original power. We removed -3. So following the formula, take your original power, which was -2, and subtract the power you pulled out. We subtract -3. So careful, there's a double negative. -2 subtract -3 leaves me y to the first power, y to the 1. Now check that. If you were to multiply these back together, wouldn't you add these powers, -3 plus 1, and then get -2? Math is awesome. All right, next term. 6 divided by 3 is 2. X to the 9th, we moved x to the 8th, still an x in there, and all the y's have been pulled out. Here is my answer. Now, if you want to put that y, that -3rd, down as a fraction in the denominator, go for it. This is the basics that I'm looking for. Okay, all kinds of negatives in this third example. All kinds of negatives. Can we pull out any coefficient? Well, you could argue either way, and I don't really care that much, that we could pull a -1 out. Since both terms are negative, you might want to do that. And that's actually totally up to you. It's the exponents on the variables that are going to be key here. So let's take a look at x. Can we take an x out? We can if it's in both sets. Let me mark my sets out. My two terms are here. And I'm going to put a plus right there since I took that negative out right there. Okay, so I removed the negative from both sets. Now it's time for x. We have a -4 versus a -3. The smaller one, the least power, is -4. Y, there's a y appearing as a factor of both. So y, which is our least power? -1, -2. -2 is the least of those. So that comes out. We put my bracket in there. And this is a plus since we pulled the negative out. And then what's still in this first set? Negatives out. 3 is still in there as a coefficient. X's have all been removed. Y, here we go. We started with -1. That was our original. -1. And we removed -2. So we take away -2. And what do we have? That is +2. That's going to equal 1. So Y has the first power on it. And then we finish with this one. X was to the -3rd. We subtract the -4. -3 minus -4 is x to the +1. And the y's are gone. So here is a factored version. Oh man, I just saw that it says simplify, factor and simplify. So maybe this would say like the 3y plus x. That's all to the +1 power. And then I could divide this by x to the 4th y squared. You see why I took those two negative powers down to the denominator? And let's not forget there's a negative in front of all of this. Let's just put that in front of the whole thing. There I simplified. Okay, one last example, and you should have a chance to practice these. So here are my sets. Let me just block them out. There they go. Okay, 2 and 10. Let's pull out the 2. X to the 5th, x to the 4th. Smallest one is x to the 4th. Quantity, same quantity. Which power is smaller? -1/2 or +1/2? Negatives are smaller than positives, so -1/2 it is, smallest one. Bracket, plus. First group, 2 came out. X to the 5th, only 4 came out. There's still 1 left. X to the negative, quantity, this blob right here, this blob to the -1/2, we removed the whole thing. So this set is just x when we're done. And we move to here, 10, we're gonna divide by 2 and have 5. All the x's are gone. How about the blob? You started with a 1/2. You removed -1/2. So what's 1/2 minus -1/2? 1 again, beautiful. X squared minus 10 to the first power. Okay, so there's a little more simplifying on this one. You definitely want to combine like terms in here, but not before you distribute. So bring down that x. Let's run the 5 through the parentheses. 5x squared minus 50. So that bracket is, if I put these in order, that's 5x squared plus x minus 50. And let me bring down the other stuff. This 2x to the 4th. Let's do this. Let's put that negative power down in the denominator. So bring that blob down as a +1/2 power. And if you'd rather write that in square root form, you just put a square root on that instead of the 1/2 power. There you go. All right, this will definitely help you when you hit the crazy algebra that you will hit in taking derivatives in calculus. So good luck. Hope this helps.